Okay, here's problem 40 on page 545. It's a triangle inscribed in a semicircle. This is sort of an application of some of the things we've done before. And if you look in your book, they take all the fun out of this problem. The idea is to find this this blue area here. So of course, what we're going to do is we're going to take the area of the circle, and here's what we're going to do. We're going to take the area of the circle, or semicircle, and we're going to subtract the area of the triangle, and that's going to be the blue area. Let's quickly do a little bit of that for crying out loud. The area of the circle, or the area of the semicircle, really, let's put a little line through that, is 1/2 pi r squared. And r in this case, if this is 10 and it's supposed to be a diameter, then r is 5. And let's just let's get a number for that real quick. 25 pi divided by 2 is, let's go with 39.27. Okay, so let's go find the area of this triangle. So your book says, oh, by the way, this is a right angle. And in fact, what they're referring to is anytime you take a semicircle and you inscribed in any triangle inside it, as shown here, you put Q any place on the semicircle arc, the triangle that results will be a right triangle. But if you do that, boy, you knock the fun out of this thing pretty quick, because if this is a right triangle, then sure enough, you've got a hypotenuse, you've got a leg, you can find the other leg over here pretty quickly, right? It's just the square root of the hypotenuse squared minus the other leg squared, so that's 100, that's 64, the difference is 36, take the square root of that and you get 6. So this leg is 6, this leg is 8. Let's call that the height, let's call that the base. The area of the triangle is 1/2 base times height, right? So in this case it's 1/2 8 times 6, so that's 48, that's 24. So down here, if I go, here's the triangle, it's 24. Looks like the answer is 15.27, which it is, but not so fast. If you're going to use that, fairly powerful trick, you kind of rip the heart out of this problem. Let's see if we can do it another way, using some of the tricks that we've learned in this chapter, namely the law of sines and law of cosines. So I'm tempted to draw this line right here. Don't ask me why. But if you do, if this is 10, this must be 5, and because it's a radius, and there's another radius, right? So now look at this little triangle right here. We happen to know all the sides, and that's a good thing. It's also an isosceles triangle, so this angle, let's call this angle P, is this angle as well too. I don't think we care about that, but we do care about angle P. We do care about angle P, and I'll show you why. First of all, let's find angle P. Okay, from the law of the cosines, we could write down that this side here squared, 5 squared, is equal to the sum of these two sides squared, 8 squared plus 5 squared, minus 2 times their product times the cosine of P. Yep. So we can solve for P pretty quickly. I can say there's a 25 over here and a 25 over there. Let's put this over there. This is a 40 times 2 is it's 80. It's always 80. 80 cosine P, and that is equal to let's see, 8. Let's write it as 8 squared, because I'm going to take 1/8 here and 1/8 there and write that 10 cosine P equals 8. So cosine P is equal to 0.8. And let me leave that just for a moment before calculating P, because now that I know P, and I know this side, I know that side, I'm going to know that side. And how does that help me? I don't think I want to do that. No, I guess what I have to do instead is to drop this little height. Let me stop and think about what I'm doing here. Stop and think, because you're scared and confused. So I can find that little height and I can multiply it by this and get the area. So let's do that. So what is this little height? I guess I'm going to run forward and find sine of P. And I'm going to find sine of P because this little height, this is a right triangle now. Drop this height so it's perpendicular to this side. So the sine of P is equal to h all over 8. Gee, there's a lot of 8's in this problem. Sine of P is equal to h. Okay, so I'm ready to say that the area of the triangle is 1/2 the base times the height. And the base in this case is 10, the diameter, and the height in this case is 8. So, what am I doing? Sine P. So, I'm resisting doing sine P for some reason. It's because I believe since cosine P is 0.8, I can write that the sine of P is equal to the square root of 1 minus the cosine P squared. That's equal to 1 minus 0.64. We're right back to this calculation. That leaves 0.36. That leaves 0.6 is the sine of P. So if I put 0.6 in to that mess, and I multiply by I multiply 0.6 times 8, I get 4.8 times 10 is 48 divided by 2. One way or the other, the area of the triangle is 24. Subtract it from this, you're going to get 15.27. So yeah, you use that. You use that hint from that problem, and you do it in 2 lines. You use the law of the cosine, trigonometric addition. You lose what you learn, and it takes you 4 times as long. Okay, let's move on.